Okay, so now we're going to look at a couple of examples where you need to use the product rule. Before I jump into those though, I've left myself a little bit of space up here because I want to add in another notation that we can use that's a little bit more convenient to represent the derivative when we're in the middle of longer calculations. So I'll show you what I mean. Here's the notation. If I write down something like this, if I have a function of x and I write it down in square brackets, and then I put the prime on the outside, that just means exactly the same as if I had written f prime of x, or if I had written it in operator notation, the derivative with respect to x of f of x. Okay, and you might ask the question, well, what's the point of using this notation? Why don't I just use this notation? Well, you'll see in a moment when we get to these examples, quite often, like if you actually have a name for the function, f, then this notation is much more convenient. But if you don't have a name for the function, and you don't really want to take the time to introduce one, this notation ends up being convenient to have if the thing inside, that you put inside the square brackets doesn't have a name. And you'll see what I mean once I do the examples right below. And yeah, so watch out for that. I use square brackets and then I put a prime symbol on the outside. And I will be honest with you, this is notation that I use. This is not a standard notation that you'll find in every single textbook that you look at. You might see it somewhere. I actually don't remember when I started using this, to be totally honest, but I find it really convenient, so I'm going to keep on using it. But now I've shown you what it means, so it doesn't seem like it's coming out of left field. So for the solution to this problem, we want to find the derivatives of the following functions, and we're given the two functions here, and they're both products. So we're going to have to use the product rule. For part A, let's jump into part A. We want to find f prime of x, and f of x is the product of x and e to the x. Those are your two factors. And remember, think of this as a guide. Here's your product rule, right? If you have the derivative with respect to x of a product of two functions of x, its derivative can be computed using this formula. Don't make the mistake of thinking you can just simply apply the derivative to this function and apply the derivative to this function and then paste them back together with multiplication after, because that doesn't work. Okay, you have to use this rule over here. And that's what we're going to do. So here's where this notation comes in. So really, what I want to do is first, unfortunately I can't have these both on the screen at once, but let's just one more time analyze how this works and then we'll jump into the example. So notice how the form of the answer. The first term has two factors. The left-hand factor is the derivative of whatever the factor on the left was in this product. And then the right-hand factor is just whatever the right-hand factor was in this product, but unchanged, right? There's no derivative on this g. It's just f prime of x times g of x. So for that term, we're going to differentiate the factor on the left, but not differentiate the factor on the right, and then we're going to multiply those together. So the first term is going to be the derivative of the function x multiplied by just e to the x unchanged. So I don't differentiate the second factor, I only differentiate the first. Okay, and then now the other half of the product rule, we got to write out this term. So this other term consists also of two factors. The left-hand factor is just the left-hand factor of whatever is inside the product. And the right-hand factor is the derivative of whatever the right-hand factor was inside the product. So what we're going to add here is we're going to go plus x times the derivative of e to the x. So this is exactly the product rule that's been followed here. And now we need to find the derivative of these two simpler functions now. And the derivative of x, remember we've seen that one, that's just going to be just 1. The derivative of x to the power of 1 is just 1 times x to the 0, or in other words, it's just 1 times 1, so which is 1. So we're going to get 1 for that one, so we have 1 times e to the x plus x times, now the derivative of e to the x, remember e to the x has the special property that its derivative is itself. So we're going to have just, this is going to just evaluate to e to the x. All right, and then now, well, this 1, we can clean this up a bit. We're just going to have e to the x plus x e to the x as our final answer. So that is going to be the derivative of this function x times e to the x. That's the derivative for part A. Okay, well, for part B, we can use the same approach. Just use the product rule. So g prime of t That's our function, is g of t, given by the square root of t times 3 plus 5t, so our derivative we'll write as g prime of t. Okay, and remember that we'll follow the same pattern. We're going to write down two terms. The first term, we're going to differentiate the first factor, so take the derivative of this one, but don't take the derivative of this one. So we're going to have the square root of t with its derivative taken, but then 3 plus 5t will just be left alone. That'll just be just 3 plus 5t. No derivative is going to happen here for this term. Okay, so that's the first term. Really what that is it's this piece, right? Differentiate the first factor, but leave the second one alone. That's really what this first term is, and that's what we have here. Now for the second term, we're going to differentiate the second factor, but leave the first factor alone. So in other words, for the second term, we're going to differentiate the 3 plus 5t, but we'll leave the square root of t alone. So we're going to have plus the square root of t times the derivative of 3 plus 5t. All right, so now you kind of see the pattern. What does this do? It breaks it down so that now you still have derivatives left. We're not done, but the derivatives we have now are no longer products. They fall under the rules that we learned in section 3.1. We can differentiate the square root of t, and we can differentiate 3 plus 5t, no problem. Okay, remember this one, square root? We've seen this one before, and it's going to be one that you get tired of doing the long way over and over and over again. So after a while, it just becomes useful to just memorize it. So I'll write out the details one more time for how we take the derivative of the square root function. But after a while, you'll just start to see me use this as if it were an axiomatic rule. So let's write down the derivative of the square root of t. We're going to calculate it for our work down here. And then whatever we get up here, we can just slip it in here on our next step. Okay, so really, how do we do this? Just write it as a power first, right? T to the 1/2 is what you have. So we're going to take the derivative of t to the 1/2, which is what? It is 1/2 t to the negative 1/2, using the power rule. But that's the same as 1/2 t to the 1/2. Right, I can get rid of that negative exponent by just moving the t down to the denominator. So I get 1/2 t to the power of 1/2. And then lastly, this is going to be, if I write it in radical notation, which is probably better since I started in radical notation, it's 1/2 root t. So 1/2 root t is really what we're going to get for this. So let's put that in. We'll have 1/2 root t times 3 plus 5t. And then over here, we've got the square root of t times the derivative of 3 plus 5t. And now if you take the derivative of 3 plus 5t, now this is a sum. So you can just simply differentiate the 3 and differentiate the 5t separately and add the results together. So the derivative of 3 is 0 because 3 is a constant. Derivative of 5t is just 5. We've talked about that extensively in the previous section. If you just have a constant times the variable, the derivative with respect to that variable is just going to be the constant. So the derivative of this second term is just going to be 5. So we'll have plus root t times 5. Okay, well what does this give us? If we clean this up on the next line down, I'll move to the left a little bit so I can hopefully have enough room. So I'll have 3 plus 5t over 2 root t. And then what else? So plus 5 root t. All right, well now, technically this is done. If we were to stop here, there's nothing wrong with that. This would be actually the correct answer, but it would be nice to get a common denominator and clean this up. It wouldn't take much work to do, and in fact, it might actually clean up quite nice. So let's multiply this 5 root t by 2 root t over 2 root t to get a common denominator. So I'll have 3 plus 5t over 2 root t plus 5 root t times 2 root t over 2 root t. And what's going to happen is, well, now we can add the numerators, right? So we have 3 plus 5t over 2 root t. Well, what's this going to be? This is going to be root t times root t. Those will combine into just a t. So the 2 square roots of t both multiply to just give us t, and then the 5 and the 10, or pardon me, the 5 and the 2 multiply to give us 10. So this is going to be 10t on the numerator. That's what this will evaluate to, 10t. So we've got 3 plus 5t added to 10t. We're going to end up with 3 plus 15t over 2 root t. Okay, and that is our answer for part B. And then what was the answer for part A? It was e to the x plus x e to the x. And so by the way, this workup here, remember this is just a kind of the details behind the following rule, which I'm just going to write now. If you have the derivative of the function square root of t, you're just going to get 1 over 2 root t. It's really handy to just memorize that because it comes up so often. It's really an interruption of your main thought process. You get to stop and work these details out over and over again. But if you forget this rule and you don't want to look it up, you can always just work this out. It's good practice to do so. There's nothing wrong with it. But after a while, you start to get sick of doing this over and over again. It's just useful to just memorize this rule and use it directly. Okay, so now we've got another problem where we're asked to find the equation of a tangent line. So we want to find the equation of a tangent line to the graph of y equals x cubed e to the x at the point given over here with x coordinate 1 and y coordinate e. So let's go ahead and do that. So we're going to need to find the derivative, right? Because the slope of the tangent line is going to come from the derivative. So start with the derivative. So to find y prime, well, what is the function y? It's a product of x cubed and e to the x. So we're going to need to use the product rule. So it's going to be the derivative of the first factor. Oop, the first factor is x cubed. So let me back up here. I started off incorrectly. So the derivative of our first factor is x cubed. So the derivative of x cubed times, I said that out loud wrong. The derivative of the first factor is not x cubed. The first factor is x cubed, and we're going to start by taking its derivative because that's the product rule. So the derivative of the first factor times the second factor unchanged plus the first factor unchanged times the derivative of the second factor, right? So that's just a direct application of the product rule right here. So we differentiate the first factor but not the second. Then in the second term, we don't differentiate the first factor, but we do differentiate the second. Just a reminder of where this first step is coming from. Okay, so, well, let's take the smaller derivatives now. The derivative of x cubed is 3x squared. So this is actually going to just become 3x squared e to the x. Now the second term, what will this be? X cubed e to the x, with the e to the x has to be differentiated, but remember, again, e to the x is its own derivative. So this is just going to stay, or just become x cubed times e to the x. Okay, so great, that's our derivative. This is nothing, but now what do we do with the derivative? Is this our slope? Not really. It's a slope. It's kind of like a slope function. It gives you the slope at a given point x. So we actually need to turn this into a slope by actually plugging in an x value. So how do we get that? Well, our slope, m, is going to be the value of y prime when x is equal to, well, whatever the x coordinate is at this point, right, which is 1. So that's how we're going to get the slope. It's the value of y prime when x is equal to 1. So just plug x equals 1 into this expression. So we're going to get 3 times 1 squared times e to the 1 plus 1 cubed e to the 1. So what's going to happen? This is really just going to be 3 times 1 squared, which is 3, right? E to the 1 is just e. So this is just going to be 3e. And the second term, 1 cubed is just 1. E to the 1 is just e. So we got 3e plus e, which is 4e. Okay, so that's our slope. And what else do we need? To get an equation of a line, you need the slope and a point that the line goes through. And good news, we already have a point that the line goes through. It's given in the question as 1e, right? If the line is tangent to this graph at that point, that means a tangent line goes through that point. So we can say that the tangent line is given by, well, just use point slope form. We can go y minus y naught, the y coordinate of this point, so y minus e is equal to m, which is our slope. We worked out to get 4e times x minus x naught, where x naught is the x coordinate of this particular point. So we're going to get x minus 1. So that is our tangent line. All right, good, we got that one done. So remember that that's going to come up frequently, right? Finding the equation of a tangent line. It always boils down to a few steps. Take the derivative of your function. That's what we did here. Plug in the point that you're given to get the slope. That's what we did on this line. And once you have that, the rest is just plugging things into the formula. We got the slope. We have a point that the line goes through. Put them together in point-slope form to get the equation of the line. Those are easy marks on an exam if you're asked to find the equation of a tangent line. So don't sacrifice those points because you forgot how to find the equation of a line, right? Make sure you remember how to do that. And it's worth your while to invest in mastering that process early because it comes up over and over and over again through the course. So there's many opportunities to get points from doing that. Okay, so the next example, and the last one on this page, is a little bit of a weird case where we've got a function f, and we're kind of given its definition, right? We said f of x is equal to the square root of x times g of x. So it's like you're given part of the definition of f, but there's this other piece, g of x, that we aren't given explicitly. But we are told some information about it. We're told that it's a differentiable function. We're told that g is differentiable, and we're told that its value at the point 4 is 2. So g of 4 is 2, and we're told that the derivative of this function g at the point 4 is 3. Now, what are we asked for? We're asked for this piece. We want to find f prime of 4. And it turns out that actually exactly what we've been given is exactly enough information to answer this question without ever actually knowing exactly what the function g is. Okay, so let's do this. We'll say f prime of x. Well, we're going to apply the product rule, right? We've got a product. Square root of x is our first factor, and g of x is our second factor. So we're going to take the derivative of the first factor and leave the second factor alone. That's our first term. And then the second term, we're going to leave the first factor alone and differentiate the second factor. So we get square root of x times g prime of x for the second term. Okay, and hey, this popped up again, the square root. Right? Remember how to do this? Write it as x to the half, do the power rule, deal with the negative exponent, change back to radical form, or just remember, right? We did this already. This was at the variable t, but it's no different. Who cares? So if you had the derivative of the square root of t, we got 1 over 2 root of t. So derivative of the square root of x is just going to be 1 over 2 root x. So take advantage of the fact that we already worked this out in general. So we're going to get 1 over 2 root x times g of x. This we can't do anything with because we don't know what g of x is. So we have to just leave it as g of x. What about the next line? Well, we don't know what g prime of x is. So we're just going to have to leave this whole second term as it is. The square root of x times g prime of x. What else can you do? Right? We don't have enough information to go any further. But what do we ask for again? We're asked for f prime of 4. So this is a general rule that gives you f prime of x with the understanding that you don't really know it exactly because you don't know what g or g prime is in general. But let's plug in 4 to figure out what f prime of 4 is. So plug a 4 in here and see what you get. F prime of 4. Well, we just worked out f prime of x. It's equal to this expression. So plug 4 into this expression. We're going to get 1 over 2 root 2. Or, pardon me, 1 over 2 root 4 times g of 4 plus the square root of 4 times g prime of 4. All right, so we can work out what this is. I was thinking about the fact that the square root of 4 was going to evaluate to 2, and then I accidentally wrote a 2 here. But yeah, the 1 over 2 root x, we plugged in a 4, so it's going to be 1 over 2 root 4 here. Then everything else, we plugged in the 4 exactly. So let's just reduce this a bit. And hey, g of 4, that was given to us as 2. G prime of 4 was given to us as 3. And everything else is just numbers, so it looks like we're fine to work this out. So what is this fraction here? 1 over 2 times the square root of 4. That's 1 over 2 times 2, because the square root of 4 is 2, right? So this is just 1/4 for that first fraction. So this is 1/4 times, what was g of 4? G of 4 was 2. And then what's the second term? Square root of 4, that's going to be 2. And then g prime of 4 was 3. So, well, just to clean this up now. 1/4 times 2. 2 times a quarter is just a half. And 2 times 3 is 6, so we get a half plus 6. So 6 1/2. 6.5 is what f prime of 4 is. And if you want to write it as an improper fraction, which we probably should do here, you can just write the 6 as 12 over 2, and then add 1 over 2 to 12 over 2 to get 13 over 2. Okay, and that's how you can write it as an improper fraction, which I think is a bit better in this case. Okay, so those are a few examples of how to use the product rule.